So, hi, this is a section on the area of a triangle, and this is sort of a general triangle, so it's not every single triangle. I mean, it is every single triangle. It's not like special triangles like isosceles or right triangles or anything like that. I'm trying to get this straight for you guys, but it doesn't really matter. Um, I'm going to just generalize everything, so I'm going to call this side, I don't know, how about A? And this will be side B. This will be side C. And that makes this angle A. I'm going to put that outside the triangle, like in the book. This is angle A. This is angle B. And here's angle C. So the idea is if you have these things, so you know the triangle, that you can, our goal is to find the area of the triangle. And the area is base times height, or 1/2 base height. All right, and that's always true. So let's look at it from the perspective of, let's call the base A in this case. So base equals A. And we could call any of them the base. And whatever we call the base will determine what we call the height. So in the case of A being the base of the triangle, the height is now this. If I drop a perpendicular, or drop a perp, as I like to say. Get rid of this guy. All right, so now I have a right triangle, and I'm going to call this H. So the area is 1/2 A times H, but I have to figure out what H is. So I'm going to use trigonometry to do it. Let me magic pen it. If you just sort of zoom in right here to that right triangle, all right, you can see that the sine, S-I-N-E, the sine of angle C is opposite over hypotenuse is sine C. So I can now say that this is 1/2 A times, so let me deal with this over here. I'll say the sine of angle C is opposite over hypotenuse, so that's H over B, which means that H, if I multiply both sides by B, H is B times the sine of C. Awesome. So now I have that the area is 1/2 A times B times the sine of C. All right, and if I knew those values, I could get it. I have length A for the area, so 1/2 length A times length B times the sine of angle C. All right, well, let me take the same triangle. All right, I'm going to clone it. Okay. And I will continue to use A, B, C, A, C, B. This is angle A, angle B, and angle C. What if I chose something else as the base? So what if I said, say, the base is actually, let's flip it and say that well, yeah, let's flip it and say that the base is C. So area equals 1/2 of C, length C, times the height. Now, if my base is this thing, right, then the height is going to be that. This right here is going to be height. All right? So, you know, I guess if you're going to diagram it, you would sort of extend this line out. Oh, I don't want to do that. You would extend this line out. Oh, there it is. If you extend this, and then drop a perpendicular down to that, undo. All right, now this is the height, and it's the height, I guess, off of this bottom. All right, if you look at the whole thing upside down, it makes more sense. I guess I could do that, but I'll draw that in class if you need me to. All right, so now here's what we have. We have the height is, or the area is 1/2 of C, that base, times whatever this height is. So to get that height, we're going to need to use this angle. So just like we did in the last one, we have a right triangle. This is the right triangle. Oops. That's the right triangle we're using right now. The right triangle is this guy. Okay. But this angle in here is no longer, I mean, this is angle A right here. Right? So this angle here is 180 degrees minus A, or pi minus A, which is what I prefer. So the relationship is that the sine of pi minus A is equal to opposite over hypotenuse, which is this length B. So it's H over B. So that means H is equal to B times the sine of pi minus A. So this is B times the sine of pi minus A. So now, what do we do with that? You know, I guess we could leave it like that, but it turns out that this is actually cool. All right, that the sine of pi minus A is actually equal to the sine of A. All right, so that's probably something we'll end up talking about in class. But what we get here is A equals 1/2 of C times B times the sine of A. All right, and we can likewise do the same thing with side B. A, C, B, big B, big A, big C. Only this perpendicular would be dropped here. There you go. And you go through much the same analysis that we just did for the previous one, and you get that area is going to equal 1/2 A times C times the sine of B. All right, so if you notice, I'll write all three of them now. We have area equals AC sine B, area equals 1/2 AB sine C. These are in your text. And then area equals 1/2 BC times sine of A. And I guess what I should do is not say A equals, but I should say area equals. Okay, I'll work through a couple examples for the next video. Okay.